number 623, add one row to tree. So the given problem is that we are given a root and a value and a depth. So we need to add that value at depth 2 of that tree. So given here we have this root and value 1 at and depth 2, we need to insert the value at depth 2. So this is the root node is at depth 1 and this is depth 2. So this is where we add our values, and everything to the left of the original node goes to the left of the new node, and everything to the right goes to the right of the new node. And yeah, so this is a recursive function, because suppose we are given a value 1 and a depth 3. So this is depth 3, we know that, and to reach here what we start from the root node and we go to the left, and then we go to the left again. Once we reach here, we add our new node, and then to add our new node here, we go to the right of this new node, right? And again we need to add at this level as well, here as well. So to reach here, we go this way, left, right, and then left. So we are actually doing the same task repeatedly. So this becomes a recursive function. So now let's write our recursive function. And one more thing, yeah, since we are inserting at level 1, we are inserting to the left of the root and to the right of the root. So we are actually inserting to the left and right of the at depth minus 1, the given depth minus 1. So we are actually inserting at to the left and right of depth 1. So we need to keep track of depth of this depth so that we can insert to the left and the right of this. Now what if in case the depth was 1, we would insert it here, and this whole tree will go to the left of the new node. In that case, what we are gonna do is that becomes an edge case. So we are just gonna check in the very first case. So let us write our first edge case. If depth equals 1, which means there is no parent to our new node, so the whole tree goes to the left of the new node. So we return our new node with value val and the whole tree to the left of the new node. And let's just check our example, check this with an example here. So let's take this example, and we're inserting at value 1 at level 1. Run this code and see, does that work? Perfect, it works for level 1. Now we need to check if there are multiple levels. So for that, I'm gonna create a function. Since we are doing DFS function, I'll fill the function in a moment, and before that I'll call the function. We return the value from that is returned from the function. So we pass the value root and depth minus 1 because we need to keep track of the depth. So here we get the root, depth, root and the depth. Now here also, if depth equals 0, we're just gonna return. And if depth equals 1, so we need to insert at depth 2. I'm passing depth minus 1. So our first call is at the root node with value 1. So which means here I need to stop now and start adding to the left and to the right. So if stop when depth is equals to 0, and then add to the left and to the right of the root equals to new tree node with the value val, and the left becomes the left of the original tree, and to the right, and the left stays null and the right becomes the right of the original tree here. And we keep, since this is a recursive function, we do need to call it from our function. Yeah, so once we have reached our depth, I'm still calling this function, and at that point of time depth equals to becomes 0, but we don't need to do any more calculation because we have already done the work that we need to do, so we are just going to stop there. That's why this return statement is here. Now what if in case I had to insert at level 3, but there was no this node, so there is no right subtree of this original node, so this value will be null then, so there is no left of null. Left of null doesn't exist, neither does the right of null. So in that case also we need to return if root is equals to null or undefined. So let's just check our example here. Let's use our original test cases. Okay, so I forgot one very important thing, to return our root. Great, working perfectly. Let's submit this. Talking about the time complexity here, since this is a recursive function and we are calling it every time we reach for each of us our root, and if the depth is at the very end, so we are actually going through all the root nodes, so it's T O of n. So the time complexity is O of n and space complexity is